minor of an element Aij in a square matrix A is denoted by Mij and is obtained or defined as determinant of the submatrix obtained by deleting the row and column where Aij is situated, that is located. See, later I will give the determinant definition. For understanding purpose, I will show you how to find 2 by 2 matrix determinant. So first of all, determinant is applicable for square matrix. Now take any element Aij in the given matrix A. So first you identify where it is located. For example, if I take A12, first row second column element, it is located. Delete that immediately, row and column. The remaining elements formed a matrix that is called submatrix. That determinant of that submatrix gives the or called the minor of the element Aij or A12, like that. Okay. See, here you remember one formula. If A is equal to a 2 by 2 matrix, which is a 10th class formula, A, B, C, D, then determinant A or modulus A, that is, it is pronounced as DETA, determinant A, and is defined as this diagonal product minus this one, BC, AD minus BC, and A inverse is equal to 1 by AD minus BC into D minus B minus CA, okay, where denominator determinant A not equal to 0, this is determinant A, okay, and this matrix so obtained by A inverse is also called adjoint of a square matrix A for a 2 by 2 matrix. Later we will come to this again determinants adjoint. For understanding purpose, how to find minor of an element in a 3 by 3 matrix, you should remember the 2 by 2 determinants. Okay. Next, 2. Cofactor, don't worry about this determinants and inverse, I will give you later. Cofactor of an element Aij is defined as capital Aij is equal to minus 1 whole power I plus j, that is minus 1 raised to I plus j into Mij. Minor of an element denoted by capital Mij. Cofactor of an element is denoted by Aij. Now what is the difference between these two? Minus 1 whole power I plus j, that is minus 1 raised to I plus j, just we are multiplying. This quantity is nothing but either minus or plus symbol only. Ij stands for positive integers, that is row position, column position. When you add, these sum becomes either odd number or even number. So we know that minus 1 raised to odd number is equal to minus 1. Minus 1 raised to even number is plus 1. So that's why some elements having minor cofactor equal and some elements having minor cofactor differ by symbol only. Numerically it is same. Okay. Next. 3. Adjoint of a square matrix A is defined as ADJA, sometimes keeping in bracket that matrix, is equal to cofactors matrix of A whole transpose. What is cofactor matrix of A means? Every element is replaced by cofactor, then the matrix so obtained is called cofactor matrix of the given matrix A, and then transpose, this matrix is now called adjoint of a square matrix A. So first of all, every element find the cofactor and replace itself, and then transpose. The matrix so obtained is called adjoint of the given matrix. Here I gave the cofactor of an element. Okay, next 4. Determinant. Don't worry, I will show you one example, all these things. Of a square matrix A is denoted by, this is the symbol for determinant, or DETA, and is defined as the elements of a row slash column are correspondingly multiplied by the cofactors and then adding, comma, the value so obtained is called determinant of the matrix A, which is I already wrote here, determinant A. That means select any row or any column. Each element is respectively multiplied by, that is correspondingly multiplied by their cofactor, and add these things after multiplying the cofactors. Then the value so obtained is called determinant of the submatrix. Remember, it can be expanded by any row or any column, but before expanding, before finding determinant, set a row or column already containing zeros, because 0 into any number, whether it is multiplying by cofactor, any cofactor, it is 0. So try to select a row which containing small numbers or zeros. If they do not containing zeros, then it is usual procedure only. Every element multiplied by cofactor and then adding. Or try to bring zeros using row operations, column operations. I will show you in problems. Okay, higher order determinants, how to expand all this. But I already given 2 by 2 determinant, this one formula. Determinant is always unique. And it can be expanded by any row slash column. Generally, the people are habituated by expanded by first row or first column only. Next, the inverse of a square matrix A is given by A inverse is equal to adjoint A by determinant A if det A not equal to 0. Okay. Here A into A inverse is equal to automatically I. That means after finding the inverse, whether it is correct or not, how you know, that is how do we know that our answer is correct or not? The only verification is multiply the inverse with the given matrix, you should get identity matrix. Okay, otherwise it's your mistake. So here also remember one thing, whenever A into B is equal to I is equal to B into A, which implies B is equal to A inverse. Similarly, we can write A is equal to B inverse. The next one is, if determinant A not equal to 0, then the matrix, square matrix A is called non-singular. Non-singular matrix. If determinant A is equal to 0, then the matrix, square matrix is called, A is called singular matrix. So with this, inverse exists for determinant not equal to 0. That means inverse exists for non-singular matrix. Similarly, a matrix A is said to be invertible, that is A inverse exists. So the matrices are invertible means for non-singular matrices only, that is determinant not equal to 0. So that means don't find immediately adjoint A whenever we require A inverse. First you calculate determinant A. Whenever denominator is 0, then does not exist, not required to find adjoint A. So some people are started with generally finding adjoint A, numerator quantity, success, you will get some other thing. Okay, you will get whatever it may be. Once you go for denominator of, that is finding determinant A, if it is 0, that is waste of time only finding adjoint A. That's why before finding A inverse, first find determinant A. Next one is, just write some more points here. Determinant of unit matrix is 1. Determinant of AB is equal to det A into det B. Determinant of the product is equal to product of their determinants. A and A transpose having same determinants. After, so just I shown you already 2 by 2 matrix determinant formula. Find that matrix transpose and check these things. Any 2 by 2 matrices. Okay, now I will show the procedure for all these things. See, for example, if I consider a standard 3 by 3 example, then I will do the gate question problem. A11, A12, A13, A21, A22, A23, A31, A32, A33. That is a 3 by 3 matrix. Now I am selecting the first element, that is diagonal element. Minor of A11, which is denoted by capital M11. How it is defined? This location is first row, first column, immediately delete. Remaining elements is called submatrix. That determinant submatrix is called minor of that element. So determinant of remaining elements submatrix is A22, A23, A32, A33. And you know how to evaluate. I shown you A, B, C, D matrix. Okay. Next. And for this element, how to find cofactor? Cofactor of A11 is nothing but denoted by capital A11, and this is minus 1 whole power 1 plus 1, that is I stands for first row, J stands for first column because A11 located in that position, into M11. So that is nothing but M11 itself. So in this A11, the minor is itself cofactor. That means both are equal. Suppose if I take A23 element, minor of A23 is denoted by M23. How it is obtained? This element is situated in second row, third column. Delete. Remaining elements, determinant. That is, remaining elements is called submatrix. Determinant of submatrix is called minor of that element. So the determinant of A11, A12, A31, A32. You know how to find this 2 by 2 determinant. I have given already before this. Okay. And for this element, what is cofactor? Cofactor of A23 denoted by capital A23 obtained by minus 1 whole power I plus j is nothing but 2 plus 3 into its minor denoted by M23. So this is nothing but M minus into M23. In this case, the element A23 minor cofactor numerically same but opposite in signs. So that is, here if you get this is plus, then it gives minus. If you get this value minus, then it gives plus. So minor cofactor for some elements same. In other cases, it is defined by symbol. Okay. Next, determinant A. If I select the first row, determinant can be expanded by any row or any column. People habituated for first row only. So first row, the 3 elements. Each element correspondingly multiplied by their cofactor and then adding. So first element in the first row A11, the cofactor denoted by capital A11. The second element is denoted by A12, which is multiplied by its cofactor denoted by A12. A11, how? I shown you how to find cofactor. And the last element in the first row is A13, which is multiplied by its cofactor denoted by A13. That is, I added. Each element multiplied by cofactor and then adding. That is, I added. This value is a number, so obtained is called determinant A. Okay. So this is expanded by first row. Okay. Or suppose if I take second column, A12 into its cofactor is A12, capital letter. Second element is A22 multiplied by cofactor A22. Last element in the second column is A32 multiplied by its cofactor A32. So this is also value obtained is called determinant of the given matrix, and this obtained expanded by second column. So take some numbers in a 3 by 3 matrix, apply by any row, any column, you will get same answer. That is, determinant is always unique, otherwise it is your mistake. And this expansion is also called Laplace's expansion, the way of expanding like this, determinant. So here I have shown you 2 cofactors. Each element is correspondingly replaced by its cofactor. You will get a some matrix and then transpose that matrix. The matrix so obtained is called adjoint matrix. Okay, after replacing every element by its cofactor and then transpose, the matrix so obtained is called adjoint of the given matrix. Okay, I shown you already 2 elements cofactors. So I am showing you one example which is given 2001, 2 marks. DET, that is, I am not writing full form, I hope that you understand. Determinant of the matrix 5, 3, 2, 1, 2, 6, 3, 5, 10. Solution. Select any row, any column. All are non-zeros only. So this is just depend on calculation only. That means time, fate also, luck also. That means here no element is 0. That means you can expand by any row, any column. It will take same time. Okay. So now determinant A. I have taken the usual procedure. The people habituated by first row. What is first element? 5 into cofactor of 5. Cofactor means before that finding minor of 5. Leaving first column first row, remaining elements determined. Okay, that is 2, 6, 5, 10. Okay, correct or not? And this is pre-multiplied by minus 1 whole power 1 plus 1, which becomes plus. Okay, now second element is 3, which is located in first row, second column. That means you pre-multiply first of all minus 1 whole power. First row means 1, second column is 2. Minus 1 whole power, that is minus 1 raised to 1 plus 2 becomes minus. So minus into that number into leaving second column first row, remaining elements submatrix determinant 1, 6, 3, 10. The last element is 2. 2 is located first row, I is equal to 1. Located third column, j is equal to 3. Minus 1 raised to 1 plus 3 becomes plus symbol. Plus into 2. Delete the first row, third column. Remaining elements submatrix determinant. That is 1, 2, 3, 5. Okay. So here by first row, this expansion by first row. Similarly at home you check expanding by any column. See that answer is same or not. Okay. Now you know the procedure of determinant A, B, C, D. AD minus BC. That is 5 into 20 minus 30. Minus 3 into 10 minus 18. Plus 2 into 5 minus 6. Now this simplifies to minus 10 into 5 minus 50. This is minus 8 into minus 3 plus 24. Minus 1 into plus 2 minus 2. So this is minus 52 plus 24 is minus 28. 2 marks problem. But even though the question is not asked for inverse, I am showing you in this problem how to find a inverse. After that make a note point. Finding A inverse. Now finding A inverse means first of all determinant we already calculated. We have determinant A is equal to minus 28 not equal to 0, which we already calculated. Whenever determinant not equal to 0, then only we proceed further, that is finding adjoint A. Now adjoint A, just this is very careful step. 9 elements. Each element first of all consecutively or respectively finding its cofactor and replace itself. See 5 cofactor. That means closing this column row, remaining elements determinant 20 minus 30 minus 10, and each element pre-multiplied by, please remember, minus 1 raised to I plus j. Minus 1 raised to I plus j will get either plus symbol or minus symbol. So that's why in many textbooks it is given 10th standard level the symbol, that means above the elements, in above above of each element they are giving symbols plus minus. Each symbol indicates minus 1 raised to I plus j. So this symbol now plus into 5, that means plus symbol, remaining minor. See cofactor of an element is nothing but first of all find minor, and minor is pre-multiplied by minus 1 raised to I plus j. Minus 1 raised to I plus j gives either plus symbol or minus symbol. Please remember this one. So 20 minus 30, that means minus 10 into plus minus 10. Okay. Now this second element 3, leaving second column first row. 10 minus 18 minus 8. Minus 8 into minus symbol, that is minus 1 raised to I plus j. That means plus 8. Next this 2 element, leaving third column first row. remaining 1 into 5 minus 2 into 3, 5 minus 6 minus 1, minus 1 into plus symbol, that is minus 1 only. Okay, next this fourth element 1, leaving second row first column, that is 3 into 10, 30 minus 10, 20, 20 into minus symbol, that means the minus 1 raised to I plus j. Okay, that means 30 minus 10, 20 into minus 20. Next, this fifth element 2, leaving second row second column, 50 minus 6, 50 minus 6 is 44, 44 into plus symbol, 44. That means in the last, after AD minus BC, I am saying plus minus symbol. That means I hope that you understand. Pre-multiplying by minus 1 raised to I plus j. I stands for row position, j stands for column position. Next, sixth position, that is leaving second row third column, 5 into 5, 25 minus 9, that is 16. 16 into minus 16. Next, seventh position, third, 3, leaving third row first column, 3 into 6, 18 minus 2 into 2, 18 minus 4, 14, 14 into plus symbol, plus 14. Next, eighth position 5, leaving second column third row, 5 into 6, 30 minus 2, 28, 28 into minus 28. Next, last element, ninth position, that is number 10, leaving third row third column, 5 into 2, 10, 10 minus 3, 7, 7 into plus 7. I hope that everyone you understand into plus into minus in the last I am saying, that is indicates minus 1 raised to I plus j pre-multiplying. Okay, after finding minor of an element, pre-multiplied by either plus symbol, minus symbol, that depends on minus 1 raised to I plus j. Okay, and then transpose. So what you will be getting, interchanging rows and columns, minus 10, 8, minus 1. So here the first row after transposing becomes first column. So in the next problems, if I ask, if any question finding inverse, means save this step. Without writing this step, whatever you are going to find cofactors, suppose if you are going by row wise, its cofactors just represent, just put in the column of the next step, so that we save this transpose of a step. Transpose means interchanging rows and columns. Now this transpose to second column, minus 20, 44, minus 16. Third row changes to third column here, 14, minus 28, 7. Therefore A inverse is equal to adjoint A divided by determinant A. What is determinant A? Reciprocal of 1 by 28 with minus into remaining adjoint A, that is minus 10. This is the procedure of A inverse. Now you verify this A matrix into A inverse, definitely it gives I matrix. Otherwise, done by myself or yourself, it is mistake only, not the question. Whenever determinant not equal 0, this after getting A inverse, you just verify multiplying with pre or post, which gives definitely identity matrix. Just here itself I will check first row with first column, getting 1 or not. 5 into minus 10, minus 50, 3 into 8, 24, minus 50 plus 24 is minus 26, 2 into minus 1, minus 2, minus 26, minus 28, minus 28 is pre-multiplied by minus 1 upon 28, which gives plus 1. That is the first element in the identity matrix. Okay, later you check all these things. So one more question I am doing, because inverse is difficult. Generally you work hard in finding A inverse. This is one more example given, which is 2005, 2 marks. If R is equal to 1 0 minus 1, 2 1 minus 1, 2 3 2, then top row of R inverse is dash. That is fill in the blanks. Now after finding cofactors in adjoint A, immediately we are transposing. That is, first row becomes first column, second row becomes second column. Top row is nothing but first row of R inverse. So R inverse is obtained by first of all determinant and adjoint A, and then cofactors, all these things. So that means top row means first row of R inverse is nothing but cofactors of which elements? First column only. These three elements indicates first column. After finding cofactors and going for adjoint A, that means putting these cofactors in a matrix A and then transpose. So this column goes to first row in adjoint A. So that means automatically R inverse is nothing but adjoint A by determinant A. So these first three elements, first column in R inverse, it becomes top row. That means in adjoint A, that is first row cofactors. Okay. See. Now I am giving an indication like this. Okay. So anyhow, first of all, find determinant R. If determinant R 0, then this does not exist. So procedure is selecting by any row or any column. Here one element is first row 0. So expand by first column. 1 into, close the first column first row. 2 plus 3, 5 into plus symbol. 0 into anything 0. And this minus 1 into plus symbol minus 1 into leaving third column first row. 2 into 3, 6 minus 2, 4. So which gives 1 not equal to 0, inverse exists. Okay. Top row of R inverse I am giving directly. Here we did not require all elements cofactors. Just see the word top row, first row of R inverse. Nothing but first column cofactors in R divided with determinant is equal to 1 upon determinant R cofactors of 1, 2, 2. This 1, 2 is nothing but first column of R. Now, this is equal to 1 by 1 into cofactor of first column, first element 1, leaving first row, first column, 2 plus 3, 5 into plus symbol 5. Second element 2, this located in second row, first column, leave it. Remaining elements determinant 0 plus 3, that is 3. 3 into minus symbol, that is minus 1 raised to I plus j. Don't forget this one. Okay. After multiplying the, finding the determinant, submatrix determinant, pre-multiplied by minus 1 raised to I plus j. So this gives how much now? 0 plus 3 into minus 3. And the last, this 2 located in third row, first column, leave it. Remaining 4 elements, submatrix determinant 0 plus 1 into here plus symbol. So finally this answer is 5 minus 3, 1. This is the answer. Good problem, logic also. Now I am giving you a problem that is doing that, an example of evaluating higher order determinant 4 by 4, 5 by 5. So just only one step. First remember the determinant procedure. Now the one step is reduce your higher order determinant into lowest order 3 by 3 or 2 by 2. So the following step is select a row or column as you like. In that selected row, except one element, make the remaining elements zeros. How to make the remaining elements zeros? Using row or column operations, elementary operations. What are the three types of operations? Interchanging of two rows, two columns. But in a determinant, if you interchange two rows, two columns, you will get minus symbol. Pre-multiply in the final step, minus symbol. Okay. So I will discuss later this one. So first of all, row operations, column operations, after that means before making except one element, remaining element 0, you apply the following row or column operations. R2 minus 2R1, R1 minus 3R2, like that. C2 plus 2C1, such type of operations. Okay. So make the remaining elements except one element zeros, and then expand the determinant by the definition method. What is definition of a determinant? In that selected row, after making zeros except one element, every element is multiplied by its cofactor and then adding. So we have only one non-zero element after making zeros. So that element into, you know how to find cofactor, I shown you. Okay. So this is a problem given in 2011. 2 marks. Value of the determinant 4 by 4 matrix is given. Determinant 1 0 minus 1 0, 4 7 0 2, 1 1 minus 1 1, 2 0 2 1. Comma is solution. What is given here? 1 0 minus 1 0, 4 7 0 2, 1 1 minus 1 1, 2 0 2 1. Now select what I told you. Select a row or column as you like. First of all, if it look at that zeros, maximum zeros containing a row or column, then go to that row, and remaining elements, if possible, zeros. Remaining elements, make them to be 0. Okay, remaining elements means except one element. After selecting a row, except one element, make the remaining elements 0. So here, see the first row, already 2 elements zeros. So in this first row, that means I am selecting first row, expanding the determinant definition, that is expanding the determinant. Before that I selected first row. So here I want to make either this one or this one 0 using row or column operations. Okay. So here I selected this element. This element means, sorry, this row. So now I want to make this minus 1 0 with the help of this one using column or row operations. So if I put the direction like this horizontally, that is applying column operations. If I locating my arm in this direction, my finger or whatever may be, if I put this direction, that is vertical direction means row operations, this direction means column operation. That means this is located in third column, this is located in first column. So how to make this element 0 with the help of 1? Just adding these two. That means C3 plus C1. C3 changes to C3 plus C1. This gives first column unchanged. Only C3 changes, third column. 0, 7, 1, 0. 0, 4, 0, 4. Fourth column unchanged. 0, 2, 1, 1. Okay. This is equal to. This is the operation maintained in the brackets. Now what is the next step? Now in this selected row, just use your definition method. 4 elements are there. Every element is multiplied by cofactor and then adding. Already 3 zeros. So this is equal to 1. First element into, what is its minus 1 raised to I plus j? First row, first column. I value 1, j value 1. That is which is pre-multiplied by the symbol plus. Into, delete that row, first column. Remaining 9 elements determinant. That is the procedure for finding minor. So 7, 4, 2, 1, 0, 1, 0, 4, 1. Sorry, not matrix, determine this one. So that means every element multiplied by cofactors and then adding. What is cofactor? Minus 1 raised to I plus j into minor. What is minor? Delete the row and column where the element is located. The remaining elements forming a submatrix. The determinant of the submatrix is called minor of that element. Now here this is a 4 by 4 matrix. Minor of every element is a 3 by 3 matrix. Now look at your previous problem. A 3 by 3 matrix. Minor of every element is a 2 by 2 matrix. I mean determinant of a 2 by 2 matrix. Okay. Now you know how to expand this determinant. So 1 into anything is 1. So expanding by second column, already one element 0, or better to go by first column, third element is 0. So first element 7. 7 into plus symbol. Leaving first row, first column. 0 minus 4. Next, second element 1 into minus symbol, that is minus 1, into leaving second row, first column. Remaining elements 4 into 1 4, 2 into 4 8, 4 minus 8 minus 4. Last element 0, 0 into anything 0. So minus 28 plus 4, minus 24. This is the value. The where I highlighted in some steps, that indicates I am expanding the determinant by that row or column. So once again I am repeating that step. Higher order determinant reducing into lower order. This is a 4 by 4 higher order. This reduced into 3 by 3. Okay, what is the only one step? Select a row or column as you like. Okay. In that selected row, using row or column operations, make the elements zeros except 1. I shown you already these two elements 0. I made this element 0 using this operation. If I am showing this direction, that is applying column operations. If I am showing this direction, that is I am going to apply row operations. Okay. Next. So this is in such a way it is reduced to 3 by 3, and you know how to expand 3 by 3, which is I shown you in the previous problem, determinant. So here why I selected the first row, already it is 2 elements 0. Okay. Suppose if all elements are non-zero, as this operation you do 2 more operations by making 0. Now one more questions using these definitions, that is you can verify by considering the respective matrix of whatever the order. Okay. And then properties also I am going to give. That means in using some properties the determinant takes less time, sometimes it may be 0. Note or just properties. One, if A is of order n, that means not required to mention separately square matrix. Order n means n rows, n columns. Naturally it is a square matrix. Then 1, determinant K into A. K is a scalar, A is the given matrix. Determinant of the scalar multiplication of the given matrix is equal to K raised to n into determinant A, comma K is scalar. 2, determinant adjoint A is equal to det A whole power n minus 1. Adjoint of adjoint A, that is 2 times finding adjoint of the matrix. First time adjoint of the given matrix, for that matrix obtained again find adjoint, and for that the determinant is following symmetrically formula, easy to remember, etc. That means if it is 3 times n minus 1 whole cube. Okay. 3, determinant of A inverse is equal to 1 by determinant A. That is whenever determinant A not equal to 0. 4, A into adjoint A is equal to determinant A into I is equal to adjoint A into A. And you remember determinant of a upper triangular matrix, lower triangular matrix, scalar matrix, and diagonal matrix is nothing but product of just leading diagonal elements, product of principal diagonal elements. Okay. These are determinant properties. Determinant of a skew symmetric matrix of odd order is 0, but determinant of a symmetric matrix of even order is non-zero and is a perfect square. See, take a 3 by 3 skew symmetric matrix, find determinant as above procedure, you will get 0. Take any 2 by 2, 4 by 4 even order skew symmetric, I shown you some examples skew symmetric, find the determinant using the procedure, you will get not equal 0 and it's a perfect square. Perfect square means 1 square, 2 square, 3 square, 4 square, like that. Okay. Determinant of an orthogonal matrix is always plus or minus 1. And here also write one more point. Adjoint of any unit matrix gives unit matrix. So take a 2 by 2 matrix, verify the above properties, which will take less time only, or you can take any order also, satisfying the left and right side of these formulas. Okay. In a determinant or in a determinant, say delta, that is symbol is denoted by delta, generally determinant A, determinant B. Okay. If Ri is equal to K into Rj or Ci is equal to K into Cj or two parallel lines are identical. Lines means generally a row or column, which is also vector. Two lines, two rows, two columns are same, then determinant equal to 0. In this case, delta is equal to 0. Okay. In a general manner, comma, a row slash column is referred as a line or a vector in matrix. Okay. Generally line means a row or column.